Hello everyone. Today I am going to explain how to assemble AlphaTroniks 555 timer based PWM DC motor speed control kit. This is the PCB which we get inside the kit with some components, and this is the manual on how to assemble this. Now the first step is how to figure out which component goes where. So let's see uh, these are some big holes here, 6 big holes, and same here. So these are the output terminals. These are the holes where the output terminals will go. For example, these ones, these will fit here this way. I'll show you later on how to do that exactly. So the main idea is how to figure out which goes where, and if the diagram is like this, you should hold your PCB like this, not like this or like this or like this. This is the correct orientation. Now these are two 1N414 diodes. The cathode of one diode is facing my left side and the cathode of other diode is facing my right side. This is a trimmer, it's a 50K trimmer. Then here is 1K. Then here is the 555 timer IC. Then here is a 0.1 microfarad ceramic disc capacitor. Then here is 470 ohms quarter watt resistor. Then here is BD139 power transistor. Then once again, these are the places where the terminals will go. So let's start it. First I'll unpack the contents. Now take any part randomly. See, the point is how to identify components. That's the most difficult part. See, it's written 103 on this capacitor. That means it's 0.01 microfarad. You can always Google and search for capacitor conversion chart. That way you can easily identify what the value of this code is. So I'm gonna fit this 0.01 capacitor. See where it goes. Here is our BD139. Next to that is a 0.01 microfarad. So it should go here. That's correct. Done. It's in place. Now I take, what value is this? It's a 470 ohms resistor. So as we saw, 470 ohms is here. We go ahead. That's in place too. Now always bend your leads once the component is fully touching the PCB surface so that they don't fall down back. Now pick any component randomly. Now these red colored things are Zener diodes. sorry, I'm so sorry. These are 1 and 4148 diodes. Sorry for that again. If you can see, it is very minutely written. See, I'll try to show you guys. 4148 4148, it's written on it. Many people confuse between Zener diodes and 1 and 4148 because all these diodes are in red color and have a cathode. So hope this helps you in identifying 1 and 4148 diode and a Zener diode. Don't mistake a 1 and 4148 diode for a Zener diode, or a Zener diode for a 1 and 4148 diode. So let me go ahead. This 1 and 4148, I've inserted D1 in place. Now I go and insert D2. D2 is right here in this place. Now I take this 1K resistor. I hope you can see all the colors. It's brown, black and red. Forgot to mention on the color codes on the 470 ohms resistor. They are yellow, violet and brown. The last color is the tolerance color, which is gold. For more information, you can Google resistor color code chart, and there you will get the tolerance for every color. There are 3 colors: gold, silver and no color. Gold is 5% tolerance, silver is 10%, no color is 20%. So now I should insert this 1K resistor. Where's 1K? Here. It's here. Sorry for going out of focus. It's here. Now this one goes here. Always bend your leads after the component touches the surface of the PCB. Now I take this remaining ceramic capacitor. Say it's 104 written on it. That means it's a 0.1 microfarad capacitor. That is C1. It goes in this position here. These two holes, small ones. It's in place. Again bending the lead so that it doesn't fall back down. Now take your IC socket. Now what's the need of this IC socket? People ask me in my store. Well, these ICs have the chips inside a plastic package, and these are the leads which connect to the actual chip inside. So, and these leads are heat conductive. If you directly try to solder the lead, it can break the filament which connects to the actual chip inside, ruining your IC. So to protect that, these sockets were invented. I don't know who invented that, but a brilliant invention. So let's see how the IC socket goes. You can see the notch here. IC1, it's got a notch here. What does the notch mean? Notch means the IC has a proper orientation. From the right side of the notch, pin number 1 starts, then 2, then 3, then 4, then 5, then 6, then 7, then 8. It always starts in anti-clockwise manner. No matter whichever dip IC you are using, always the IC, the first pin starts from the right side of the notch. Hope you guys understand like that. So same way, there's a notch on the IC socket also. You can see, I think so. I'll try. Yeah, see, there is a small notch here, and the other side is perfectly flat. So now the notch is on my left side, and the PCB will accept the socket both ways, but take care, go according to the data sheet. So I insert it now with the notch facing left side. It's a little bit tricky getting all the pins inside all at once. It's gone. Brilliant. Now you can bend the corner leads to prevent the socket from falling down. Done. Have a look, have a nice look. Now what remains is these terminals. There are 3 of them which will go here. Sorry for going out of focus again. It will go here, here and here. Before inserting those, we have to cascade them. These get attached like Lego bricks. See, there are notches here. There's a male notch here and there's a female notch here. See, my nail can go in, not too deep, but there is, and it gets locked this way. Similarly, do for the last one. There are total 3 sockets like these, and you can insert this. Always these terminals will face the open side, or you can call the wire accepting side, on the outside of the PCB. Always remember that, a thumb rule. Now see how the BD139. Now the main thing is how to figure out how a transistor will be sitting on the PCB by just looking at the data sheet. See, here you can see a little bit more taper towards the outside and a thick gray line that indicates the heatsink tab side of the transistor, which is this aluminum part is the one which radiates heat. Now we have to insert it like this, with the aluminum heat radiating side this way. A heatsink is optional. If you want to install a heatsink, then you can solder the transistor little high so that you get room for inserting your heatsink. Well, this BD139 is a 1.5 ampere epitaxial silicon transistor. What does 1.5 ampere epitaxial silicon transistor mean? That means it can sink up to currents of 1.5 amperes. Now I should solder all those components which I have inserted. I'll temporarily disconnect the transistor and I'll solder it once I've finished soldering all these rest of the components. Now, and lastly, we will be joining some wires to the pot and the other end of the wire to these three wires, three holes here. These three holes, it's optional whether you want to use a trim pot or a pot. It's one and the same, because people like mostly to control the motor speed just by turning a knob, so we supply knobs with the kit. Take your soldering iron now, make sure it's well hot, decarbonize your tip. I will say this in every video, by wiping it to a wet sponge or steel wool, because PCBs don't get soldered nicely if there's carbon on the tip. See, my tip is very clean now. Now first I would like to solder my terminals. Now don't forget to cut your remaining leads after soldering. Use a cutter. This is a diagonal cutter. I have finished soldering those components which I had inserted. Now we will solder the transistor. You can bend it if you want. Now solder it. Done. Now we are going to solder wires to the potentiometer. I am using a 3-core wire. It has 7 strands inside it. Now I split these just using my hands because these are easy to sorry, I'm falling short of my vocabulary. These are easy to separate. Got it. Lol. Now I use a wire stripper. This can cut too, but it does not cut that well as this one, the blue one. This yellow one is good for stripping wires. Now twist the wires after you strip them. Now give a solder coating, which is technically called tinning. Hold your wires like this between the middle finger and the ring finger, and hold the solder between your index finger and your thumb when you are soldering with one hand. Now bend your pins of the potentiometer. Now give it some solder. These pins need a lot of solder, and do it as fast as possible. Solder the middle pin first. Let it cool down. I'm blowing air from my mouth. Now solder the second wire. Now solder the last wire. Done. Now take the other end of the wire. Separate the 3 wires. My vocabulary just got stronger. Lol. Strip the wires. Do the same thing, but strip a little bit longer because this end will be going in the PCB. I got about 8 mm of wire stripped out. Now twist it. And tin it. Notice again I am doing the tinning by holding the wire in the middle finger and the ring finger, and the solder wire in the index finger and the thumb. Finish all the 3 wires. Cut off little bit. And insert. Now there's an important part. Please see carefully. The middle wire will go here in the middle pin here. Take care of that and do it properly. First solder that one. Done. Now if you want the motor to go fast as you turn the pot clockwise, then you must connect the pin which is on the left side of the middle pin to this pin here. Let's do that. In this case, this white wire will go here in this hole. Now I solder the white wire. Now I'll solder the remaining yellow wire to this point. Done. Now I cut the extra wires. Now your kit is 99% assembled. Why 99? Because this IC still has to go in its place, which will make it 100%. Now you notice that the IC's pins are tapered towards the outside, little bit this way and this way. We have to converge them a little bit so that it will go in the IC socket. How to do that? There's a technique here. See, take your IC, hold it like this. Hope you can see all this. Hold it like this. Take a flat surface, press it down a little bit on one side and a little bit on the other side. Now see, these pins have converged. Now it will be easier to insert it into the IC socket. Take care, the notch is facing left, so the notch of the IC also should face left, and hold it, place it properly so that it makes contact with all the pins, and press it in one go using only your thumb if it's a small IC. Now our kit is fully complete. Now you can see, guys, here it's shown where the positive supply, that's VCC, and the ground will go, and these middle pins are for the switch in case you want to add a switch and switch your kit on and off. And here are the last two terminals are for the motor. Take care you give proper supply in the right polarity. So I'll just mark it down. This is plus, this is minus, this is switch, this is motor. Plus minus DC supply. Now I'm gonna use a 9 volts battery connector and insert it into the terminal here. The red is positive, it goes to the plus. I hold it like that. I take my screwdriver, a flathead screwdriver, tighten it, done. Now similarly the negative one, the black one, goes to the minus here. Tighten the screw, it's tight enough. Now if you want, you can go and put a switch, which I don't need right now. I just take a lead, a cut lead of a resistor, and bend it in a U and insert it inside the terminal. Press it in and tighten it. Now I have chosen a DC motor, a miniature DC motor. We sell these motors on a website, www.alphatroniks.com. That's AlphaTroniks.com. Now take some piece of wire. This is a 2-core wire. It's got 7 strands. Separate the 2 wires. Strip off some insulation. Twist the wires. Tin the wires. Now tin the terminals of your DC motor. Since my motor is small, I am able to hold it between the middle finger and the ring finger. I tin it the same way as I tin my wires. Then I solder the wires to the terminals of the motor. Done. Now I separate the other end of the wires, strip some 8 to 10 millimeters. 8 mm is fine. These wires will now go to the output terminals on the PCB where the motor goes. Here, here, here. Now tin your wires. Insert it into the terminals. And tighten these screws to make a proper sturdy contact. And we are done. The kit is fully complete. The kit does not come with a DC motor or the piece of wire or this 9-volt snap. Now I take a 9 volts battery. I connect. Make sure that the proper polarity is observed. Now you can see this little bit bigger, more hollow type of pin here and a round pin here. This one will accept positive DC and this one will accept negative DC. Like here, see, this is the positive. In the battery, the positive is round, and on the cap the positive is hexagonal. So insert it. My motor has started. Wow, tighten. It's really a tight contact. Now let's see if it varies. Yes, it does. Let's see, this pot is in minimum position. Now as I turn it a little bit more, fan rotates. I have reduced the pot, or you can say I have turned the pot fully anti-clockwise. Now I am turning it clockwise. If you can notice the whine, as I move the pot more towards clockwise, the whine increases. I reduce, the whine decreases. It's the PWM frequency which is making the noise. I'm making some funny sounds. I hope you don't get to listen to them. Now let's power it full. Slowly turn your pot clockwise. This is the full speed on a 9 volts battery. Thank you guys for watching my video. Hope you can build your kit after buying it from our site www.alphatroniks.com. Please share and like our videos and subscribe to us. We are doing a lot of big efforts to make these videos and kits. Thank you guys. Have a nice day.